Swarm technology allows large numbers of UAVs to work together towards real-world applications. In these swarms, the UAVs are autonomous and they react to their local environment, and this allows the swarm to be robust, to scale to large numbers of robots, and it also allows them to be adaptable to different missions. The challenge with swarm technology is, given the number of UAVs, how can a single operator on the ground simulate very quickly the swarm algorithms to see if they'll work, and then monitor in real time what the swarm is doing and control what the swarm is doing in real time? And that's really where the digital twins come in.
Okay, aircraft safely in loiter. I'm going to unblock the API and let swarm control take off the other two aircraft.
Our digital twin can be used as a tool to create different missions and plan them. So it will allow swarm operators to task, let's say, a swarm to explore or monitor an area. In this particular case, we are seeing a wildfire, which the swarm will need to identify in a specific part of our world. So the swarm operator can in real time control the swarm, and essentially the swarm can monitor this particular area to identify this wildfire.
All under swarm control.
After the aircraft have taken off, the swarm operator is able to take over and task them to perform a stack at a specific location of the airfield. Once the operator sets them into a searching pattern, they're able to perform a random search whilst remaining enclosed within the area and avoiding each other. If the swarm operator sees that the aircraft don't really respond to what the operator wants them to do, or if they want to choose a different searching strategy, they're able to choose a different pattern, like a pheromone dispersion, and change the behavior of the aircraft. So now we can see the aircraft moving onto a straight line, depositing information about their previous locations to the swarm. After this has been completed, we can see that the aircraft changed their behavior in real time. We can change a different searching pattern, and we can task our agents to perform this searching pattern. So we see now that they've changed the behavior from a pheromone dispersion to what we call a dynamic space partition. And that allows them to explore the area more effectively and separate the required searching world into different segments. Our digital twin allows the swarm operator to not only control real aircraft, but also create digital ones, which they will essentially allow the operator to control a larger swarm with more aircraft, both virtual and real. After a successful launch, and after we've seen that the operator is able to change searching patterns and searching behaviors, we're also able to task our swarm to land. Set the landing direction to 135 degrees.
The trials are being done with simple aircraft to show how this swarm technology works, but in the future we hope to use Ultras, which are aircrafts that can go very far, can carry heavy payloads, and that would then make these missions that we're aiming for credible. Today's tests are all about monitoring forest fires. The idea is if we can catch them really quick, we should be able, even using the UAVs, to extinguish them before they become a problem. In the future, this swarm technology we think will be useful for anything where we need to cover a large area. So you can think of large-scale aid delivery, you can think of environmental monitoring, and hopefully this core infrastructure, the digital twin and the swarm operator, make this credible.